Okay guys, so in this lesson we're going to be talking about long division or synthetic division using polynomials. This synthetic division is used to also factor and find roots of polynomials. Now this example that I'm going to be talking about works out nice and evenly, nice and perfect to illustrate these notes. However, in real life and later on in the book, it's not going to work out so simple, but you guys are smart. You can kind of fill in the dots and connect everything. All right, so if I were to give you this polynomial, x to the fourth minus 8x minus 3x to the third plus 24. You know this is an even degree polynomial because it's x to the fourth. So it's going to resemble some kind of a quadratic going up. You know, this could go up and down. Possible 4 roots. What if I were to tell you one of the roots is 3? One of the roots is 3, factor it. You probably would look at this and go, I don't know how to factor. This is a 4th root polynomial, I have no idea. Well, there's something called synthetic division. Synthetic division is used to find roots and to start to factor. Now, synthetic division is going to seem weird for a second. It's just a pattern in order to use it to advance to the next step. It's going to seem like weird, like mambo jumbo for a second, but it'll make sense in a little bit. To do synthetic division, the very first thing you have to do is you have to line up the polynomial with the highest degree first and decrease it by 1 every single time, all the way until you get to positive 24. Now I'm going to cross this off as I do it. So I have x to the fourth. My next thing is negative 3x to the third. My next thing is I don't have an x squared, but it has to decrease by 1 unit every time, by 1 exponent. So I don't have an x to the squared, which is the same thing as saying plus 0x to the squared, because 0 times anything is just 0. But you have to list it in decreasing order, and then after this I have a negative 8x. Okay, so now this is the exact same thing as this. The reason why I have to do that is because I have to use something called synthetic division, because the original question was factor this. Okay, now I know that one of the factors, if I have a root of 3, I know that one of the factors is x minus 3. But I have to have a couple more factors in order to get this big old polynomial right here. I find this by using synthetic division. So what I do is I take one of the roots that I know goes into this. One of the roots is 3, and this is how you're going to set it up. You're going to put a 3 on the outside, and then you're going to list every single coefficient on the top. I have a coefficient of 1 here. I have a coefficient of negative 3. I have a coefficient of positive 0 or just 0. I have a coefficient of negative 8 and of negative 24. You have to line it up from your highest exponent dropping by 1 exponent every time. Now, with this, here, this is step by step on how to do this. The very first step that I do is I bring down this first term. I always bring down the first term, and then it's robotic. You do the same thing every single time. What you're going to do is this. 3 times 1, write it here is negative 3. I'm sorry. 3 times 1 is positive 3. And then the second step, add these 2 rows together. Negative 3 and positive 3 is 0. And repeat, 3 times 0 is 0. Add these rows together to get 0. 3 times this 0 gives me 0. Add these rows together to get negative 8. 3 times negative 8 is a Sorry, that should have been a positive 24, not negative 24. 24 plus 24 is 0. Okay, so now this looks crazy, right? Just a bunch of numbers everywhere. Well, what we're going to do is make this make sense now. So what happens is this is your coefficient. You started with x to the 4th. What happens is your first term right here is 1 less every single time. So we start as x to the 3rd, a positive 0x squared, positive 0x minus 8, and this is a remainder. And I'll show you what happens when there's a remainder other than 0 in a second. So my answer, this is my answer. Now I'm going to clean this up. I have 1x to the 3rd. I don't have an x squared. I don't have an x. And I have a negative 8. This last row right here is always your remainder. Let's say you had a remainder of 3. You added these two together to get 3. Your answer would be with a remainder of 3 over what you divided by. Okay, but anyways, we don't. So going back to the original thing, if you want to stop it and rewind back to the beginning, that big polynomial, the question is, how do I factor that big polynomial? If one of your roots is equal to 3. Okay, remember I told you, if one of your roots, sorry, my dog keeps coming in and out. If one of my roots is equal to 3, I know the factor of that is x minus 3. So that is one of the factors. Now, this answer is my other factor, but this x to the 3rd and this x to the negative 8 is actually called a perfect cube. I'm going to go over how to factor a perfect cube in a second. So I'm going to leave this up here, and then looking on the notes, I gave you x squared minus 16, and I asked you, the very first thing on the notes, what's that called? Difference of squares. How do you factor x squared minus 16? It's the difference of squares. So to factor x squared minus 16, this is going away from this for a second. I'm coming back to this, and you'll see why I did this in a second. But going off your notes, x squared minus 16 is, you take the square root of both terms. One's a positive, one's a negative, and then you could solve it from there. The next, I go step by step. This is the factored form, and then this is kind of review. I talk about setting it equal to 0, solving, you would get negative 4 and positive 4. Okay. The next thing I give you is a different difference of squares. I give you f of x equals 25x squared minus what, 64? All right. And I say solve or factor. Well, when you're factoring, you always set your y, your function value, equal to 0. Square root of 25, square root of x squared, square root of 64. One's a positive, one's a negative. So your roots would be, if you set this equal to 0, it would be negative 8/5, positive 8/5. That's easy when you have a difference of squares. Now, look at the next thing. It says perfect cubes. This is a perfect cube. How do you know it's a perfect cube? Because x times x times x is x to the 3rd. It's called a perfect cube. 2 times 2 times 2 is 8, which is a perfect cube. So therefore, I'm going to be teaching you how to factor perfect cubes. And I give you guys 2 more, and I'm going to ask you to factor the ones in purple, 27x to the 3rd plus 125 in a second, and 1,000 minus y to the 3rd. I'm going to ask you to factor that in a second. So the next page on the notes, I give you perfect cubes, but I write it out in Mathanese. But this is IM3 STEM, so you should understand the Mathanese version of this. This I give you as a to the third minus b to the third. Now, the way you factor perfect cubes is just a pattern. The pattern for this is you cube root this term. You cube root this term. And then I give you a big polynomial right here. What happens is you take this term and you square it. You take this last term, and it's always a positive, and you square it. Okay. This middle term in your binomial is the same of this little binomial. And this middle term is always the opposite. These two are the product, which goes here. Or in English, you take a and b and you multiply a and b together. This is how you factor this. Now, I'm going to erase this, and I'm coming back to this because this is in the form of a perfect cube with a minus sign. The only difference is if you look in your notes, if this is a positive, then that means this is a positive and this is a negative. Everything else is done exactly the same. Whatever your binomial is in here, that's what your binomial is in here, and then the middle term is the opposite. So once again, if this was a positive, this would be a plus b, this would be a squared minus ab. These two are opposites, these two are the same. Hopefully that makes sense. Okay, now what I'm going to do, I'm going to leave this here, and I'm going to factor this using this pattern. The cube root of x to the third is x. Look what I do from here to here. I square this term. So I'm going to square x. This is a minus. And then look, these middle terms are opposite. So my middle term is a positive. Okay. Now, the cube root of 8 is 2. What happened from here to this last term? I took b and I squared it. So I'm going to take 2. Don't worry about the sign. I'm just taking this number, 2, and squaring it and putting a 4. Now, I'm going to multiply 2 times x is 2x. And ladies and gentlemen, this big term right here is this factored. That's called factoring difference of cubes. Now, if you don't believe me that this big thing is this right here, watch. I'm just going to multiply everything out real quick, and you're going to see that everything cancels out to, in fact, get this answer. This product of a binomial and a trinomial is the same thing as this perfect binomial cube. Watch. X squared times x is x to the third. X times 2x is positive 2x squared. X times 4 is 4x. Negative 2 times x squared is negative 2x squared. Boom. Negative 2 times 2x is negative 4x. Boom. Negative 2 times 4 is going to give me a negative 8. And then look, once I factor everything out, I'm going to have these squares cancel out. I get x to the third minus 8. And this is the exact same as this binomial right up here. Same thing. Everything ends up canceling out, which is great. All right, I'm going to go back to the first page. Remember I told you a second ago, I want you to try and find the, let's go back to the very first thing on this note. Remember I told you they gave you that big polynomial, and I said one of the roots is 3. Factor it. Well, your answer would be x minus 3 times your answer that I just had right here. X minus 3 times that binomial times that trinomial. That is that big polynomial factored. Okay, let's see if we can factor out perfect cubes now. The very first example, you know what, let's just go on to the bottom one. I give you the cube x to the third minus 64 and I give you the answer to that. But let's go to the next one. Y to the third plus 8, x to the third plus 216. I'm going to do x to the third plus 216.